In this video, we're going to cover wave basics. This will include parts of a wave, types of waves, as well as properties of waves, which include a frequency and period. We're going to start off with the concept of a pulse. So a pulse is a single brief disturbance that travels through a medium. So if I disturb this, let's say this is like a slinky, I disturb it over here, we get this pulse. What is moving across here is the energy. And if we were to make multiple disturbances, we would get a wave. So a wave would be a repeating disturbance that transfers energy from one place to another without transferring matter. So it's important to understand that what's transferring here is the energy and not the matter. Now we're going to take a look at the parts of a wave. So here is a simple wave. At the highest point, we have what's called a crest. At the lowest point of the wave, we call this the trough. And this dotted line is the equilibrium, or sometimes referred to as the rest position. From the equilibrium to the crest, we have what's called the amplitude or the equilibrium to the trough. So this is like your maximum displacement here. Also, we can measure from crest to crest or trough to trough, and that length is called the wavelength. So the wavelength is the length of one wave. You can measure it once again from the crest to crest or trough to trough, or you can even measure it from the equilibrium location right here to not the next one, but the one after that. So it's going to continue. You're going to measure to the length until to the point where it starts to repeat itself again. Now we're going to take a look at two categories of waves. The first type of wave we're going to look at is called a transverse wave. And a transverse wave, the medium moves perpendicular to the wave direction. So here the wave is moving to the right. The disturbance that caused the wave is going up and down, so it's perpendicular to the direction of the wave. In a transverse wave, we have crests, which is the highest point, and troughs, which are at the lowest point. An example of a transverse wave would be light. Another type of wave is called a longitudinal wave. And these have a medium that move parallel to the wave direction. So here's a slinky. Imagine you bunch it together and then you let it go. And then you have this wave moving to the right. And in a longitudinal wave, the disturbance is parallel to the direction of the wave. So the wave is moving to the right. The energy of the wave is moving to the right. But if you look at one part of the slinky, it's just going to be moving back and forth, back and forth. In a longitudinal wave, we have compressions, which is where the slinky is bunched up. And we also have rarefactions where it's more spread out. Another category of waves is whether it's a mechanical wave or electromagnetic wave. A mechanical wave is a wave that requires a medium. An example of that would be a sound wave. Without a medium such as air or a liquid or solid, we can't have any sound. Electromagnetic waves, however, don't require a medium. And examples of electromagnetic waves are visible light, radio waves, and microwaves. And even though in space, which is pretty empty, light can still travel through space, it does not require medium. However, sound wouldn't be able to travel in space. So if you had an explosion in space, you wouldn't be able to hear it. In movies, obviously, they put sound effects in there to make it more exciting. But in order for there to be sound waves, you have to have a medium. And this medium does not have to be air. You can be underwater, take two rocks and bang them against each other and you can hear them. Sound waves can also travel through solids as well. Now we're going to take a look at some properties of waves that we can measure. The first is period. So period is the time to complete one cycle, and this is measured in seconds. And frequency is the number of cycles per second, and this is measured in hertz. So period, we use the capital letter T for period is equal to 1 over the frequency. So period and frequency are inversely related to each other. We can also write frequency is equal to 1 over the period. And we'll take a look at some example problems. So let's say that the period were 2 seconds. So this is the time to make one complete wave. So the frequency would be 1 over 2 or 0.5 hertz. Let's say that we're given the frequency. The frequency was 4 hertz, and we want to find the period, and the period would be 1 over 4, or we could say 0.25 seconds. We can also measure the speed of a wave, which we refer to as the wave speed. The equation for wave speed is v is equal to the frequency times the wavelength. The symbol for wavelength is a Greek letter lambda. And let's take a look at an example. Let's say that the frequency of a wave is 5 hertz and the wavelength is 2 meters. So to find the wave speed, we just take the frequency times the wavelength. So we have 5 times 2, and we get 10 meters per second. Now let's say that we're given the wave speed of 60 meters per second and a frequency of 10 hertz, and we're asked to find the wave length. So we can rearrange this algebraically, and the wavelength is wave speed divided by frequency. So we get 60 divided by 10, and the wavelength is 6 meters.